Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Sana, and I'm joined by Gagan tonight. We are broadcasting live from the Allan Carswell Observatory, which is located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which, just like York Universe, runs between the hours of 9 to 10 p.m. local Toronto time. If you are not following us on our YouTube channel, please head over to our website, yorku.ca/science/observatory, and follow the links to our YouTube page to access our online public viewing. We've got a chat running, and we are showing some archival images taken from our 1 meter telescope. So you'll be able to see some cool not live imaging, but cool archival imaging, and ask any questions you might have in our chat. Unfortunately, it is pretty cloudy and rainy and terrible outside, so we are not able to bring you any live imaging tonight, but you can still enjoy some of our past archival images. For any questions or comments you have on our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. Or if you'd prefer, you can always connect with us on social media, on Instagram with the handle at Yorku Observatory and on Facebook at Allan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, please see our website at yorku.ca/science/observatory. We will be monitoring the chat room in the OPV for any questions to post some content. So please do engage over there if you can head over to the OPV. Gagan, how are you doing tonight?
I'm doing well. Weather's not great. I would hope for better, with everything that's going on right now, but we're doing all right. How about you?
Yeah, pretty good. Good. So I think the weather is, I think, the normal complaint of every astronomer that it's always terrible. Um, we've had a
Yeah, we
couple.
have,
Sorry, go ahead.
sorry? No,
Oh no,
I think we were about to say the same thing. We've had a
yeah.
couple good nights and then mostly overcast.
Yeah, that was exactly what I was going to say. Last Monday, for anybody who was watching the OPV, was very clear. There was some nice live imaging of, I think it was the Polaris constellation last week. Um, but unfortunately, I don't think we can get 2 weeks in a row of clear skies. The Toronto weather just will not allow that.
Yeah, and there have been a few nights where I believe you guys have had to close up shop in the middle of some planned observations because clouds just roll in so fast and we do not want to risk rain in the 1 meter.
Yep, that's happened. But we do have our weather station now, which can do that for us. We did an all night observing. We left the 1 meter to its own devices with a scheduled shutdown time, and we got clouded out in the middle of the night, unfortunately. But the weather station did close the dome on us, so we were kind of asleep and not paying attention, and it protected our telescope for us. So. Uh,
Yeah, that's excellent.
yeah. So it's a lot of fun having that working now. It's a lot easier to observe. We don't have to constantly check up on the weather every 2 minutes. The weather station will just do our job for us, which is pretty nice.
Oh yeah. I mean, there were a lot of clear nights back in the day where we would just set the telescope to observe, and then we would try to get the dome to a position that would give us maximum viewing. And then the dome would just be open until the next morning when we got back to school and
Yeah.
would go and close it. So better than that because that was risky because who knows when rain's gonna sometimes it's not on the forecast and you just get a little sprinkle. But yeah, I mean, this is definitely a way better system.
Oh yeah. I sometimes think back to the way we used to operate with the 60, and it's honestly scary that we did that. I mean, it worked well, got a lot of great variable star data with the 60, but yeah, we would just kind of trust Toronto skies to not downpour on us randomly.
Yeah, like no, and you know, I think we were pretty successful. Like it never actually rained on us.
Yeah, I can't really think of any time that we left the dome open for the entire night and had disaster. Um,
No.
Yeah, so we can kind of be careful about it, yeah, but it has happened more than once where the forecasts just like completely lie. Like
Yeah.
the other night we were trying to observe and Astrospherics like swore up and down it's going to be clear all night. And then we get there and it was like spitting rain, which is just no, you lied. You don't know what you're
Yeah,
talking about.
seriously.
Yeah.
Even on Friday night, I was it Friday? Yeah, Friday night. I was supposed to, well, we were trying to observe the aurora. And on, I think, clearsky.net, it had my location as clear from, it was like partly cloudy at 1 and then completely clear from 2 until 6 a.m.
Mhm.
That wasn't really the case. I think I maybe had 40 clear minutes in that entire period, and
Yeah.
did stay awake.
Yeah, we have an all sky cam on the roof of the observatory now, so we can actually see the cloud cover and everything. And
Nice,
I
yeah.
checked in on it a couple times on Friday thinking because the forecast said it was supposed to be clear. So I was thinking we'll catch some aurora on the all sky cam, but it was overcast every single time I looked. So I don't
Yeah,
know.
and the
It was
clouds were it was super windy, like clouds moving in very quickly. So it was
mm,
kind of a toss up.
yeah, yeah. Oh well,
Yeah.
Toronto, usual Toronto weather. We just got to be grateful for the one clear night every now and then that we get. But
Yeah.
yeah.
Actually on Friday night, I had my friend and his mom also on standby. So me and my brother, we were all gonna actually go out to a bit of a darker sky site up north if the aurora was out. So we come outside and we can see it from my driveway. And it was pretty dim though. Like we couldn't really get many of the colors without being out there for too long. And I have three neighbors who are obsessed with their pot lights on all sides.
Oh
So it's like I have floodlights everywhere. So it was perfectly clear. And we were like, okay, we need to go. We need to get in the car right now. So we get in the car and we go. And in the 15 minutes it took for us to drive out there, we were overcast.
no, no.
Yeah,
Yeah. Yeah,
fun times.
the one most frustrating thing I remember was we were trying to observe Saturn. We came in the morning to try and observe Saturn in the early morning before the sun got too high, and the clouds that day were just so annoying. It would clear up enough that we could open the dome, and then by the time we had the dome open, it was overcast and we had to close. And then in the few minutes that it took to close the dome, it cleared up again. And I remember just being in this like relentless cycle of like closing and opening the dome because it was just not staying clear for long enough to be able to do much. Um, I think that was the most frustrating observing run that I've had was this really ridiculous. Like I swear the weather somehow knows that we're trying to observe and then we open the dome and then it says, no, 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 you're not doing that right now.
No, it is actually sinister because why it happens so many times. And especially with the change of seasons, I feel like cloud cover comes in and out within 5 minutes.
Hmm.
Like today, I left my jacket at home, and I was like, it's super clear. I won't need a jacket. The second I parked my car at the parking lot at York, it started raining, and I had to
Oh.
walk 5 minutes to my building with a t-shirt on. So it was great. I had a great time.
Hmm. Yeah.
But yeah, all right. Should we get
Yeah.
started with some This Week in History?
Yeah, yeah. I think we could complain endlessly about Toronto weather because it really does suck. But yeah.
Yeah.
Um,
If you guys want a whole show on that, please let us know. We are willing to do it.
oh yeah, I would definitely like to vent some frustrations, speak to the manager about the weather about
Oh
what is
yeah.
going on.
Send us
Um,
your complaints. We'll read them on air.
yeah. Yeah, I think we should do a whole show about that, but maybe not tonight. Because we have a whole other interesting things to talk about, starting with two observatories that don't have to worry about the weather. So this is the first This Week in History item is on May 14th, 2009, the launch of the Herschel and Planck space telescopes. Both of these missions were led by the European Space Agency, or ESA, with collaborations with other space agencies, primarily NASA. Now, because these were ESA-run missions, the telescopes launched from Europe's spaceport Kourou, French Guiana, aboard the Ariane 5 rocket, which for anybody who follows JWST, this is the same location and launch vehicle that actually brought JWST up into space. So for reasons that I couldn't find necessarily a reason for why they did this, but I just assumed that it has to do with launch costs and convenience. Herschel and Planck actually launched together. So ESA sort of stacked them onto each other and put them both into the same Ariane 5 rocket, which then launched, brought them both to the location where they spent their lifetimes, called the Lagrange 2 or the L2 point. It's located about 1.5 million kilometers away from the Earth. So both of these telescopes launched together, arrived at the Lagrange 2 point together, and then sort of separated and went on with their lives and completed their missions sort of on their own. So while Herschel and Planck launched together, the two space telescopes had very different scopes, very different kinds of missions. So to start off with the Herschel Space Telescope, Herschel was a 3.5-meter diameter telescope that observed far infrared and submillimeter light. So these are submillimeter is also considered radio wavelengths of light. So these are sort of towards the lower energy end of the electromagnetic spectrum, where the wavelengths start to increase and get longer, and frequencies also get kind of shorter for these far infrared and submillimeter wavelengths. Now, Herschel was a very influential telescope at the time because it was the largest infrared telescope that had ever launched into space. And it was also the first space telescope that was able to observe these submillimeter wavelengths. So it really was able to provide an entirely new picture on the universe, and it impacted a whole bunch of different areas of astronomy. So just I guess, a quick summary of some of the maybe not most important, but some of the very important discoveries that Herschel had during its lifetime. It studied a whole bunch of things in our solar system, which included studying planetary atmospheres, comets, and moons in our solar system. So this helped to just learn about, the way planets form in our solar system and the history of our solar system by studying some comets and asteroids. Herschel also took extensive observations on the way that stars and planets outside of our solar system formed. So, this included studying star forming regions and protoplanetary disks. These protoplanetary disks are essentially just disks that are around young stars that are newly forming that will eventually go on to make their own solar systems just around other planets. So, the progenitors to exoplanets, basically. Some of the really cool things that it found when it was studying these star forming regions and protoplanetary disks was that it found the first hard evidence for water in these star forming molecular clouds where stars are going to go on to form. And it also found the first kind of convincing evidence for molecular oxygen, with this molecular oxygen just being the same kind of oxygen we breathe. So the O2 molecule, two oxygen atoms sort of attached to each other. Now, of course, the O2 molecule and water are both very important components for life. So, by studying the abundances and by discovering these molecules in star-forming regions and protoplanetary disks, it was really able to learn more about the chemistry that happens in these systems, which I think will ultimately help understanding sort of how life could form and how stars and planets were able to form themselves. On top of studying things within our own galaxy, Herschel was also able to study very distant galaxies in our universe, including the most distant known galaxies that were known at the time. They're no longer the most distant known galaxies thanks to James Webb, because that is kind of knocking everything out of the water. But at the time, it did study the most distant galaxies that had been known and provided some very important constraints on galaxy evolution and how these galaxies form and evolve. Now moving on to the Planck Observatory. Planck was also a radio telescope, but unlike Herschel that studied a whole variety of different areas of astronomy, Planck really had only one purpose in life, which was to study the cosmic microwave background, or the CMB radiation. So the CMB is basically just the afterglow of the Big Bang. This is radiation that was released about 300,000 years or so after the Big Bang, and it's still visible today. Although when we observe it today, it can only be observed as microwaves, hence the name the cosmic microwave background. So what Planck was doing was literally just creating multiple all sky maps of this cosmic microwave background to study it. And the purpose of doing this is that the CMB observations can really provide a lot of important information about cosmology. So it can tell us things like the age of the universe, it can help us measure how fast the universe is expanding, and also measure matter densities. So essentially, how much dark matter, how much dark energy exists in our universe. There had been a couple of telescopes, space telescopes, that had mapped the CMB in the past, but Planck was distinct to these past observatories because it really provided the most sort of up to date, the highest resolution, and most detailed maps of the cosmic microwave background than ever before. And even today, several years after its launch, this launched in 2009, it's now 2024. So even now, the Planck Observatory still is, I think, kind of the standard for a lot of cosmological measurements, where a lot of people rely on the measurements that Planck made about cosmology. So in total, Planck did 8 all-sky surveys. The first all-sky survey from Planck was released in 2015, and then there were 2 later updated versions released in 2015 and 2018. The 2015 release had some updated data compared to the 2013 release, and then the 2018 one just included some kind of updated processing techniques to really make the data as high quality and as good as it could possibly be. And just to give you an idea of how important the Planck Observatory was and how important these measurements that it made was, is that the updated 2018 paper from Planck has 10,000 citations. So a whole lot of people really rely and use these measurements that came out of the Planck Observatory. So yeah, this was a happy launch anniversary to the Herschel and Planck telescopes, both very, very influential missions that came out of the European Space Agency. Unfortunately, now both Herschel and Planck are decommissioned. Herschel was decommissioned in June of 2013, and then Planck in October of 2013 when they ran out of coolant. Telescopes like these actually have to be cooled in order to function properly. So once they run out of coolant and are no longer able to cool the instruments, you just can't use the telescope anymore. But definitely great missions. They each had 4 years in space, but they really made their mark. So happy launch anniversary to these telescopes.
Wow, yeah, pretty prolific telescopes.
Hmm. Yeah, I see the Planck paper being cited all the time when I read papers.
Yeah, for sure. The
Yeah,
they're both at L2?
yeah, they were both at L2.
Yeah.
Yeah, L2 is kind of a convenient location um to put spacecraft. It's just sort of the way it was described is it's like it's very far away from us. It's several times further away from the Earth than the Moon is, for example. But
Yeah.
for observatories like Hubble, or sorry, not Hubble, Herschel, Planck, and James Webb, it's kind of far enough away from the Earth that it's not, you can kind of block out the light that comes from bright things like the Earth, the Moon, and the Sun. It's close
Yeah.
enough to be able to have like convenient data relays, and it also serves as a good spot to put telescopes because it's I don't know if stable is the right word, but it's a nice spot because when you put something at L2, it'll just sort of naturally follow the Earth around its orbit around the sun. So it helps to also cut down on fuel consumption. Basically, you do still have to do some sort of orbital corrections to keep the spacecraft orbiting around L2, but it's kind of just cost saving, fuel saving location to put things. So yeah, a whole lot of telescopes go to L2.
Oh yeah. And like obviously the web is over there, so and
Hmm.
it has a lot of um I guess they plan webs so that they could minimize coolant. So if they have the huge like foil
Hmm.
shield and everything like that.
Yeah, exactly.
But yeah.
Yeah, there's only one instrument on James Webb that requires coolant, which is the mid-infrared instrument. Unfortunately, when you get to the mid-infrared infrared, like you have to use coolant. There's no way around it. But yeah, James Webb, the three other instruments don't need coolant because of the sun shield.
Yeah. So it'll continue running, I guess, far longer.
Yeah,
Hopefully.
it'll
Fingers
run
crossed.
until, oh yeah, yeah, it'll run until it runs out of fuel. Um,
Yeah.
definitely fingers crossed, knock on wood. Um,
Yeah.
yeah, but we should probably move on to your next item, which is another interesting space station.
Yeah. So I'm going to be talking about Skylab. Skylab was one of the very early space stations that we had. So back in the day, there were a lot of really small space stations. Like when we think of the ISS is a humongous space station that's just literally flying around the Earth. And it's so bright that we can see it very clearly from the Earth with the naked eye. It's like the brightest object in the sky next to the moon when it's flying by. It's about like almost as bright as I would say as Jupiter when it's at opposition, almost maybe a little less bright. So back in the day, there were a lot of really small space stations. Like the Soviet Union ran, I think, six total space stations between their Soyuz and Salyut stations, as well as Mir. So that would be seven. And then China operated the stations Tiangong 1 and 2. But in comparison to the ISS, these are minuscule. Skylab was one of these early space stations, and it was the only space station to be fully operated by NASA. And it was launched on May 14th in 1973 atop a Saturn V. So Skylab was occupied for 24 weeks between its launch and May 1974, when it was not occupied after that. And over the course of its life, it housed three crewed missions of three astronauts apiece. So it was not a very big space. There were various experiments conducted aboard Skylab. This was one of NASA's first opportunities to really observe the human body in space for a long period of time with planned experiments. And yeah, they did have the moon missions, but I guess the moon missions were more focused on getting us to the moon and not really figuring out what we were doing on the way there. Yeah, there was a lot of um, I guess we had a lot of gauges to see how the human body was handling space travel. So the astronauts had to wear like heart monitors and blood pressure monitors all the time. But on Skylab, that was the first time that they could actually do experiments and see how they were operating in space over the course of several weeks. So this was a really great opportunity for them. And they also had a lot of other science experiments going on. So they had technological experiments, they had instrumental experiments, they had life sciences experiments, medical experiments, and other biology experiments that were related to like other life on Earth, like plant growth and things like that. And one of the really cool things about Skylab science objectives is that they actually also carried out experiments for 19 student research proposals. So they had a submission where students could submit a proposal for Skylab research, and the astronauts on board were doing experiments to do research for these students' protocols. So it was a crazy, awesome opportunity for young scientists. And it was also just a really good test period for habitability in space. So previous space crews had complaints about living quarters, and they also had complaints about the food quality, because I guess when we were sending astronauts to space early on, we were only caring about them getting their nutritional requirements and not really about palatability and how the food tasted. So astronauts had things to say about that. So when the Skylab missions came around, NASA took it upon themselves to kind of improve the food quality, improve the taste and also texture of astronaut food. I think now astronaut food is great compared to regular Earth food, but back then it was all just the freeze-dried stuff that we had to rehydrate. We being as if I was on Skylab, but anyway. So they did a lot of stuff to make the spacecraft more livable, and they also were doing EVAs at Skylab. So this is one of their first opportunities for extravehicular activities and spacewalks, which is basically what that is, to make repairs to the craft during the missions. And one of my favorite logs from one of these mission reports is one of the crew on Skylab 2 craft said that they fixed one object by repeatedly hitting it with a hammer. So these were some pretty crude early EVAs, but they actually managed to extend, I think, the lifespan of Skylab by a little longer than what was expected because they were able to make some instrumental repairs on equipment during the EVAs. So the Skylab missions were a success. It only operated for just over a year, but definitely laid the groundwork for the ISS in the later years and has space stations are a pretty successful endeavor now, and now we have the Artemis moon uh, station coming up. So we also have some pretty awesome space stations in planning, and this is definitely one of the early ones that contributed to the science behind living in space.
I really like that repeatedly hitting it with a hammer comment.
Yeah,
There's so
like
many things to be said about Skylab, but that's pretty funny.
yeah, it was, I think it was the one of the early EVAs on the very first crewed mission. So it's like these guys' first time out there on the craft. And yeah, they were like, we hit that thing with a hammer a few times and it was fine after that. And it was fine, I guess, until Skylab 4. So they had Skylab, which was the original launch, and then the three crewed missions were Skylab 2, 3, and 4. I'm not
Hmm.
sure if any of the crew overlapped over those three missions, but they all spent, I think, a total of how many weeks? 24 weeks aboard Skylab. So
Hmm.
not too long. Like I know now astronauts will spend many months. They'll do 24 weeks almost on their own. Um,
Yeah,
but yeah, back then
yeah.
it was less. It was probably 8.
And they now have coffee on the International Space Station that they can
Yeah.
drink out of cups because there's these new like zero G friendly cups. So instead of drinking out of like the pouches that astronauts usually drink out of, there are now cups on the International Space Station.
Yeah.
Pretty fun.
And they deliver food now to the ISS like every 3 months, which
Hmm.
they just get refrigerated food. They
Yep.
have some dehydrated food, but it's like crazy. They just get full meals now. Um, what did yeah, there's a lot of stuff that's going on with space food nowadays, which is a lot better than just like freeze-dried meatloaf with vegetables mixed into it that I think they were getting back in the day.
Yeah.
And its
I mean,
only purpose was to do dietary requirements, and they were just eating like crackers.
yeah. I mean, could you imagine doing one of these like long-term ISS missions to just eat that the whole time? Like it's the nutritional requirements, but from a more like, I guess I'm not sure what the right word is, but from other perspectives, like that's just horrible. To have to leave
Yeah,
everything
it would,
to
I'm sh
space and then have to eat this terrible food the whole time.
yeah, I'm sure it would be a nightmare. I saw
Mhm.
this photo where they're like making pizza on the ISS now.
Yeah, I saw one of those pictures too. They can make their own pizzas. Yeah.
Yeah, so they definitely have improved quite a bit. You get coffee from a cup is excellent.
Hmm.
Boiling water, pretty good. I guess they've always had that. That's all they needed to rehydrate their food, but spaghetti
Yeah.
from like a packet of like instant noodles all the time is that would be kind of a lot.
Yeah. Yeah. So it's definitely good like that life in space is not totally just geared towards surviving, and it's more like you can actually have a semblance of a life when you're in space, and it's not just completely focused on work and staying alive, right? Which definitely very very important things for the longer term space missions that, like you said, were kind of neglected in the early days of space flight. um
Yeah. Like one of the things they mentioned in one of these where they said they um in as opposed to the originally planned cramped quarters, they actually gave everybody their own space that was the size of a small closet,
mhm.
which is where I guess their bed would be and where they could keep their stuff. But back, I guess, in the early ones, it was like, okay, here's your room that you're all living in, your 8 by 8 by 8 room that everybody is
Exactly.
going to share for
Yeah.
the next 8 days.
Yeah, it's interesting, like, if you watch I got curious at one point, and I watched a whole lot of videos about, like, what it's like to live on the International Space Station. And yeah, it's literally just these sort of like broom closet sized things, but it is your own room that you have a sleeping bag in for the bed, and you can have a computer in there and kind of your own space that's sort of yours. And I think astronauts just kind of as a whole have a lot more privacy now, especially when you're living on something like the International Space Station than I guess the early astronauts did.
Yeah, and they generally just have a lot more space in general. They have more lab space. They have usually a dining area and like a common area
Yeah.
in addition to their little bedrooms.
Yeah.
So it does work out a little better. I think on one of the missions I was reading about, they were like, we added a window for comfort,
Mhm.
um, which is excellent. I guess that works great. And they also said, I think it was noted that the astronauts didn't want movies or TV. They actually wanted music and books. That was what they decided
Oh.
on in terms of in-flight entertainment.
Oh, that's actually pretty interesting. I hadn't realized that.
Yeah, so I guess they kind of back then it was like, oh, we have to send these VCRs up to, with a
Right.
tape player and and a box TV.
Yeah, I guess that
And I
sorry, go ahead.
oh that was it. Yeah.
No, I guess that's not too much of a problem anymore because you could just I mean, I don't think the internet is super, super fast up there, but I mean, you could just download some stuff to a computer and take that up with you.
Yeah,
Astronaut.
like you could just have a USB.
Yeah, yeah.
USB full of your books, your movies, your TV,
Hmm.
your
And they
music.
do have
It
internet.
would be totally fine.
Yeah.
Sorry, they
Yeah,
do
but
have what?
I think they do have internet on the International Space Station. It's not super great, but um
Yeah,
there
they
is
definitely have something. Yeah.
mhm, yeah.
We see their tweets all the time, so although those might be being sent from home.
Oh, I love the social media pages of astronauts. I follow a whole bunch of astronauts on Instagram because I just love the cool space videos they always post.
They're
Um,
so great, and their pictures are they're like, "Good morning," and they're, hundreds of kilometers away, just posting a picture of the whole Earth.
mhm,
Excellent.
yeah, it's definitely really cool. Um, yeah, so Skylab was absolutely one of the most or one of the more influential missions to I guess modern spaceflight and how humans live in space. Um, but we
Yeah.
are at the halfway point and are not even halfway through our news, our this week in history. So we should probably move on um,
Yeah.
from Skylab. But so we're going back to 2009, so a few years after Skylab. To May 18th, 2009, another Space Telescope history item, which was the final servicing mission to the Hubble Space Telescope. So, a bit of background on Hubble. It launched in 1990. It's a NASA run mission with some collaborations with European Space Agency. Hubble is a 2.4-meter diameter telescope that primarily observes visible light. And unlike the other space telescopes we'd been discussing, it's actually fairly close to the Earth in low Earth orbit, so at an altitude of around 550 kilometers. Now, Hubble launched in 1990, so at this point, it's over 30 years old. For space telescopes, that is pretty unheard of. It's a very, very long time for a single observatory to be operating. And really, the whole reason why the Hubble Space Telescope was able to operate for this long is because NASA launched five separate servicing missions to the Hubble Space Telescope between 1993 and 2009. So these missions were basically just to sort of repair certain components of the telescope. So the very first servicing mission in 1993 to the Hubble Space Telescope was actually to repair a very, very tiny deformity in the Hubble Space Telescope's primary mirror that was making all of its images blurry. So, this first servicing mission was basically to install a system which was essentially the equivalent of putting a pair of glasses on the Hubble Space Telescope to fix the issue with the primary mirror. And then the subsequent missions were all just to kind of upgrade equipment and do some typical observatory housekeeping or station keeping, just to keep the observatory operating properly. I know there were 5 of these missions in total, but today we're talking about the 5th and the final servicing mission to the Hubble Space Telescope, which happened in May of 2009. This mission was part of the STS-125 mission, whose primary goal was to service the Hubble Space Telescope. The STS-125 mission was a space shuttle mission aboard the Space Shuttle Atlantis. Is it Atlantis? I think it was Space Shuttle Atlantis. And as most space shuttle missions go, there was a crew of 7 astronauts on this mission: Commander Scott Altham, pilot Gregory Johnson, payload commander John Gunsfeld, and then 4 mission specialists: Michael Massimino, Andrew Futzel, Michael Good, and Megan MacArthur. So the mission was actually originally scheduled to happen in 2004, but that was delayed by 5 years until 2009 after the failure of or the loss of the space shuttle Columbia. So once that investigation had wrapped up and NASA had deemed that the space shuttles were safe to fly again, they started to prepare for a final servicing mission to the Hubble Space Telescope to just sort of repair several different aspects of the telescope, give it updated instruments, and really just sort of keep it working for as long as possible. Now, STS 125 was really jam packed with a whole bunch of different things in order to sort of prepare Hubble for its last servicing. So a couple of the different things that they did is that the astronauts removed 2 old instruments and installed 2 new ones. They included the Wide Field Camera 3 and the Cosmic Origins spectrograph, which both provided pretty significant upgrades to the previous generations of instruments that had been on the telescope. They also repaired 2 instruments on the Hubble Space Telescope. One of them was the Advanced Camera for Surveys, which stopped working in 2007 due to an electrical short in the camera, and the Space Telescope Imaging Spectrograph, which failed in 2004 from a power failure. Because the mission was delayed, they were also able to install a backup to the Science Instrument Command and Data Handling Unit. This is a pretty important part of the Hubble Space Telescope because, just like the name suggests, it really controls all of the different instruments on the Hubble Space Telescope and is also responsible for controlling the flow of data through the telescope. It's such an important system that NASA actually installed 2 of them on the Hubble Space Telescope, one as a primary system and then a second one as a backup system. And a couple of months before the mission was originally scheduled, or not originally, but the original 2009 launch date, one of the Science Instrument Command and Data Handling units failed. So NASA actually pushed the mission back by a few months so that engineers could construct an identical unit and it could replace the one on Hubble that had failed. So this is just providing an extra backup in case the backup unit fails again, that the telescope can still continue to function. It has a backup unit to rely on. So those were kind of the biggest things or the biggest sort of tasks that astronauts did to service Hubble. But they also ended up doing a whole bunch of other things to just kind of help expand the lifetime of the Hubble Space Telescope. This included upgrading all of the basic spaceflight systems. So they installed new batteries, with the old batteries that they replaced being 18 years old by that point. So we got some nice fresh batteries that were also more advanced than the previous batteries. They installed new gyroscopes and also installed new protective blankets on certain areas of the telescope in order to just shield the instruments and other sensitive parts of the telescope from the harsh space environment. So overall, they really did kind of a huge, I guess, refurbishment of the Hubble Space Telescope in this very last servicing mission, and really left it with five functioning instruments on the telescope and put it pretty much just in a good state to continue operating. Um, so yeah, definitely a very important servicing mission for the Hubble Space Telescope. Unfortunately, the last one that actually went to Hubble. It would be really nice if it could have another servicing mission, but probably not going to happen given it's like over 30 years old at this point. But yeah, I'm definitely hoping Hubble continues working for a very, very long time.
Yeah, no, Hubble has exceeded its lifetime by such a massive amount that it's almost shocking. But yeah, the repairs that they did on all these different missions were definitely crucial to its success.
Yeah. I do the same thing with the Wii all the time.
Yeah, the colloquial we went to space, we went to the moon.
Yeah.
I'm not even alive at the time.
I know, but I mean, I don't know.
Yeah,
Astronomy is just one like big community, right? So that's at least what
yeah.
I.
Final servicing mission, I was 10. I know.
Yeah, I am not looking forward to the day that Hubble stops working. Especially one of the more concerning things is that there really isn't a replacement for Hubble that's in space right now or on the books. James Webb, I know, is kind of called the replacement to Hubble, but it's really not. James Webb is primarily an infrared telescope, but Hubble was primarily an optical telescope. And both kinds of light tell you different things about objects in space. So while James Webb is fantastic, it's not Hubble, and we'll definitely be losing a great astronomical resource when Hubble dies. So definitely not looking forward to that day.
Do you think they would ever consider another fix-it mission?
I really don't know.
Like
I
if
mean,
it was like a really easy fixable issue?
I don't know. I mean, I would really love to believe that if Hubble failed, all of a sudden NASA would say, "We're going to try and fix this," but they've got so many other things going on right now that I don't know if they would.
Yeah.
Um,
And the money for a
yeah,
servicing mission would be
yeah.
astronomical.
Yeah.
Haha.
And the other big thing is that there's really no convenient way to service things like Hubble at this point. Like the Crew Dragon and the other, we'll talk about the Starliner launch in a second, but these are definitely great ways of getting to and from the International Space Station. But kind of the big thing with the space shuttle is that it had this cargo bay and the Canadarm that could go and grapple onto things and bring astronauts out to service satellites. And as great as the commercial crew programs are, they just don't have that capability. So there's a whole bunch of logistical issues in being able to service things like Hubble without the space shuttle.
That's
Unfortunately.
true.
Yeah. But
Yeah.
anyways, we should probably get going, and yeah, we are just going to go right to the reminders today. So for those of you who are listening, you are currently listening to York Universe, broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please visit our OPV chat for any questions or to look at some nice archival images that our crew is posting over in the OPV chat. You can navigate to that by going to yorku.ca/science/observatory. So we do have a couple of reminders for this week. First off, the Starliner launch. Starliner was originally scheduled to launch last week, but unfortunately, they had a bit of an issue with the Atlas V rocket that Starliner was going to launch on. So that launch has now been delayed to Friday, May 17th. And if all goes to plan, this will be the first ever crewed flight of Boeing's Starliner spacecraft. It'll be bringing two astronauts, Butch Wilmore and Suni Williams, to the International Space Station for only a pretty short stay in today's terms for 8 days. So this will just serve as a bit of a crewed test flight to the International Space Station, with the overall goal for Boeing's Starliner to work basically in a similar capacity to the SpaceX Crew Dragon missions, doing part of NASA's commercial crew program, which helps shuttle astronauts to and from the International Space Station for their typical crew rotations. So fingers crossed for the May 17th launch. I was really looking forward to the one that was supposed to happen last week, but unfortunately, they had to delay that for safety reasons. But Gagan, you also have a couple of reminders.
Yeah. So, like we like to remind you guys, Spot the Station at .nasa.gov is a great resource for you to find your very own um, ISS spotting time. So you can put in your location and you can check out what times the ISS is going to be visible in your area and tells you the exact information about where it'll appear, where it'll disappear from the sky, and how high it'll go. There are some great viewing times in Toronto this week and next week. So keep your eyes out. I'm actually very sad that it's overcast today because Spot the Station has listed for today maybe the single best ISS viewing opportunity that I have ever seen listed on this website. And that's with the ISS going directly overhead for 7 minutes. And it's going to reach basically the zenith. It's going to be 90 degrees in the sky directly overhead at its peak. That happened about 23 minutes ago, and we didn't see any of it. But I hope that happens again. We've got some really great viewing times coming up within the next week and a half. You should be able to spot it on any clear night. You don't even need it to be that dark. I think any time after any basically any viewing time that they'll list out for you will be around or just after sunset, and you should be able to see the ISS pretty clearly. It's a very fast-moving, bright object, and it does not blink, so that's how you can tell that it's not a plane, and it moves really fast, and that's how you can tell it's not a star. So keep your eyes peeled. Definitely check the site. NASA updates locations and sightings all around the world, so you can put in any location and it'll give it to you. So definitely take a look there. I also have an announcement about the observatory doing a tour this Wednesday. So this Wednesday, May 15th, from 8:30 p.m. to 10:30 p.m. in the observatory domes, our observatory team is running a public tour. Tickets are available on Zephy, and please find more info at yorku.ca/science/observatory. It's a great opportunity to see the domes, see how the telescopes work. If you have kids, please bring them out. It's a great time. If you're an adult and you have questions about space, it's also a great time. And if we're lucky and it's clear, the telescopes may be in operation. So you will have the chance to observe through the telescopes on your own.
Yeah, the forecast for Wednesday is kind of flip-flopping. This is back to complaining about Toronto weather, but fingers crossed we do actually get clear skies for Wednesday. It is a lot of fun playing with the 1 meter.
And the tour will continue regardless of whether it is overcast or clear. The only thing that might be different is whether you're actually able to observe using the telescope or not. But if not, you'll definitely see some archival images, see how the observatory team works in the observatory, and it's a great time. So please come on out.
Yeah, yeah. All right, so I think we're probably a good time to do one of our news items. Gagan, you want to kick off our
Yeah.
news section?
So I don't know if you guys heard, but this weekend we had a crazy geomagnetic storm, and that caused some pretty intense auroras to be seen all around the world. And while we were a little bit unlucky with the cloud cover in Toronto, as per usual, there were auroras seen as far south as Hawaii, on the southern hemisphere, New Zealand and Australia. Some crazy bright and extremely active aurora sightings, even in places that did not have dark skies. So here in the GTA, not too far out from Toronto, we were able to see some pretty intense auroras, which was frankly an opportunity that I never thought I would have. I always thought that if I wanted to go see the Northern Lights, I was going to have to travel. I was going to have to go really far up north, into the Arctic Circle or something, or to Iceland, or one of the other countries where aurora sightings are more common, like weekend trip to Alaska just to see the Northern Lights. And the tough part about the aurora is that it's pretty unpredictable. You can go on a trip and you can try and find it, but it's not really something you can plan ahead of time because it all relies on geomagnetic storms and how they interact with Earth's magnetic field. So auroras are basically a light phenomenon that we see from the ground, where solar flares, so coronal mass ejections from the sun, travel towards the Earth, and they basically hit the Earth, and the magnetic field around the Earth interacts with these coronal mass ejections, and it causes an excitation of different elements in the atmosphere, and the excitation of these different elements, and then coming back down from their excited state, is what causes us to see these very bright, very active moving lights in the atmosphere at nighttime. and they're not super uncommon, but are very regionally restricted. We usually only see them around the poles, and they're brighter closer to the poles. So people who live pretty far south, even so, like I said, Toronto, we don't really see them very often. But if you go a little bit farther north, you might have the opportunity a few times to see it. But this was an exceptionally large solar flare that occurred on, I believe, Friday afternoon, and there was some higher coronal mass ejection activity going on in the previous week. So we were expecting something a little crazy, and what we got was nothing short of that. So it was a crazy opportunity. I hope that our listeners got out to go see it. I know that weather was very unpredictable. Sana, you mentioned earlier that it was cloud cover the entire time, and even here where I am, it was definitely a lot of spotty cloud cover, and we only had a little bit of free time. So I think the observatory is going to be posting some of the aurora pics that some of us were able to take. So definitely check those out. But I know a lot of photographers had really great opportunities to take these pictures of the aurora that they would never have had the opportunity to do for in places like Texas and Florida. So definitely a once in a lifetime kind of thing.
Yeah, and I've seen so many pictures of these aurora, and it's just so gorgeous. Like there's green and these purple aurora, these different colors. It's really remarkable. Um, I am so jealous of everybody that got to see them.
They
Um,
were honestly so difficult to even see with the naked eye. Like
really.
if you weren't looking for it and you didn't know what to look for and you just looked up at the sky for a second, it would have just looked like a small cloud to you.
Mm,
Well, that's how I felt here in Toronto because we don't really have dark skies, so you don't
yeah.
get the colors that you would get out in the countryside.
Yeah, yeah, that's a good point. Um, I guess this is also a good time to talk about the fact that we are approaching solar maximum right now. Um, so the sun goes through this 11-year sort of cycle of maximum and minimum activity, which is associated with things like coronal mass ejections. So this is a really, really good time to be paying attention to the sun. There's a lot of activity on the surface of the sun, so a lot of sunspots, and that also produce a lot of really cool things like the aurora. So I know this is definitely a rare event to get aurora that is this strong that you can see them as far south as people were able to. But we are approaching solar maximum, so I think this is a good time just in general for things like aurora.
Yeah, and there are also like apps that you can get. Like I know there's site websites that will give you notifications. So I have an app that gives me like a forecast of an aurora sighting. And honestly, this app has been, I forgot I had it because it's been sitting quietly on my phone for maybe 3 years now. And I don't think I've ever gotten so much of as a peep out of it. And then on Friday afternoon, it was like, look at the sky right now. Look at the sky right now because you have northern lights in your area.
What's it called?
Um, I think it's just called Aurora Forecast, and it's like a purple and blue app, and it's a free app. It just tells you where the forecast is. And today it's like basically nothing except over Antarctica. So if we have any listeners in Antarctica, there is um a little bit of activity going on down there. And they also have a map of cloud cover. So it'll tell you everything you need right here. And it basically goes on a color scale. So they'll assign a color to the intent or like the likelihood of you seeing an aurora. So I think if you have it's like black or dark gray, it's like less than 10%. And it goes all the way up from green, orange to red. And red is like a 50% chance or higher of seeing the aurora. And the best I think I've ever seen in my area is between 10 and 15%. And I've never actually seen it before. But on Friday, it was like the entire area was just red. And basically half of the northern hemisphere was red. And they were like, you need to see the aurora today. I think
Yeah,
I was
there's
up until like
also
5 in the morning.
yeah, I stayed up pretty late trying to see it, but it just yeah, I live in kind of a light polluted area, and between that and the clouds, I just probably just couldn't spot them because they were so faint. Um,
Yeah.
yeah, but yeah,
I
the
know sorry, go ahead.
oh yeah, no, I was just gonna say like on top of the apps, I think most of the apps probably get their information from NOAA, the National Oceanic and Atmospheric Administration. They do a lot of these like predictions for aurora, so that's another great resource. It looks like yeah, tonight is not looking particularly fantastic, but tomorrow is kind of maybe there's a bit of an increased chance of aurora. Um, so I've been kind of poking around a lot on their website, and there's a lot of really cool things on there.
Yeah, I know in some areas, if the cloud cover is exceptionally light, so like just a really small smattering of clouds, and it's in a very dark sky area, like if you're in like rural northern Ontario and there's nothing around for miles, sometimes people are able to see the light through the clouds, but that was not the case here. It was pretty dim.
Yeah, yeah, but it's still really remarkable of how far south you were able to see some of these events. It's honestly a little
Yeah.
scary to think about. Like it's so cool to be able to see this, but it's definitely scary just to think about how powerful the sun is. That with how far away the Earth is from the sun, it's still able to produce these like gorgeous phenomena in our night sky. Um,
Yeah, and it's also kind of dangerous because coronal mass ejections are it's like massive amounts of energy being targeted in the Earth's general direction. And while we do have a magnetic field and that kind of protects us from these solar flares, they can cause things like power outages, which I think Vancouver had during over the weekend, and it can cause a lot of interference with the electrical grid and things like that. Luckily, we haven't experienced something of that scale recently, and even with the size of this coronal mass ejection, which, by the way, if anybody wants to go check out, I think, believe NASA actually has a video that we're always doing constant observation of the sun and it's all recorded. So there's a video of the coronal mass ejection that you can see on the sun's surface and you see it spewing coronal material out into space. So definitely take a look at that if you get the chance. But it like coronal mass ejections and solar winds and stuff, that's what kind of stripped Mars of its atmosphere because Mars doesn't have as strong of a magnetic field that Earth does. And so that's why Mars' atmosphere is very thin, very, not much there at all. It's like a really small layer of air, whereas Earth has a very thick atmosphere compared to like Mercury or Mars.
mhm. Yeah, and one of the things you just mentioned is the sort of sun monitoring satellites. If anybody is curious what the sun looks like in near real time, the Solar Dynamics Observatory actually puts live images of the sun, or well, close to live, not like live down to the second. So you can actually go through some of their archives and look at how the sun has evolved over the past sort of few weeks. You can even make little movies out of it, so you can see how the different sunspot groups sort of move around on the surface of the sun and interact with each other and grow and change, which is definitely a lot of fun to play around with. I wasted a little bit too much time making videos of that over the weekend because it's I don't know, it's so cool.
It's a lot of fun. There are a lot of the research that is done through government agency. It's all open source. So you can go and take a look at all these images for free. They're all online. They're uploaded. I believe the policy is within 48 hours after they're taken. Is
Uh, I think there's
uh,
actually some more recent ones. Well, I'll look it up now. Yeah, if you just Google the Solar Dynamics Observatory, the sun now. Um, what is the timestamp on this? So I think this is in Universal Time, but no, they actually have images from a few hours ago.
oh, lovely. Yeah.
Yeah.
This might be a bad reference, but I believe in The Martian, they said that NASA had to release all images they took of the surface of Mars. within 48 hours. And it wasn't that, I guess it's not that they release at 48 hours, but it's just that they had found Mark Watney alive and they could not wait more than 48 hours to do a press release
Hmm.
because the
Yeah.
public would figure it out first.
Yeah. You can actually, if I just pulled up one of the pictures, but you can kind of see the group of sunspots that caused this coronal mass ejection that did this amazing light show for us over the weekend is just sort of moving off of the part of the sun that we can see. So we have to say goodbye to that little group of sunspots that really dances around on the surface of the sun. Um,
Yeah.
yeah. There'll be lots more solar activity to come in the coming years. So I don't know, maybe we'll get another chance at this insane auroral activity again. Fingers crossed.
Yeah, keep your eyes out. It's definitely going to be a great time. We are nearing the top of the hour. So, everybody, you've been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Sana and myself, Guggen. You can always connect with us on Instagram with the handle at York Observatory and on Facebook at Allan Carswell Obs. And please check our website for show notes, content, updates, and contact info at www.yorku.ca/science/observatory. Thank you for tuning in. Clear skies and have a great night.
Have a good night.